One thing that can make working with data difficult is the presence of outliers in your information set. As stated earlier, outliers are extremely large or extremely small observations for the variable that you are testing for, which aren't representative of the rest of the sample. One number that's way higher than everything else, one number that's way lower than everything else. They can indeed influence your statistics in ways that you don't want. It's especially true for any summary measure, which uses a calculated average like the mean or the standard deviation. One bad number in there can throw off the entirety of your information just from its undue influence. This is even worse the smaller your sample is. A sample of 1,000 can handle one outlier probably without greatly distorting the information that you have. But if your sample size is 10, one outlier in that sample can have a huge effect on the numbers that you are working with. So you got to figure out what to do with these outliers, and you got to figure out how you're going to identify these outliers. Well, what to do with the outliers really depends on what you think is best. There is no preset rule that you have to follow for outliers. Some people will say that the observation is completely random, and even though that outlier is not representative of the rest of the data, it is a possibility, and therefore it would be wrong, fallacy, whatever you want to call it, to exclude a number from a set when it is something that actually happened in the set. Other people have the thought that it's not a good predictor and you should get rid of them. Sometimes, though, you will have numbers in your set which make no sense. If you go out and you poll people, you'll have people that make errors with their numbers. Even sometimes you'll have people that are, for the lack of a better word, trolls that give information that is ridiculous and could never possibly happen. If you have a number in your set which you are certain was not what the person you were polling intended, it was an error some way along the line, or even in your collection process, someone was doing data entry and they must have had a typo somewhere or something. If you have a number that that just can't reasonably be part of the sample set, you should always discard it. So what to do is entirely up to you. Do you want to keep the outlier? Do you want to discard the outlier? If you are going to discard the outlier, are you going to remove that whole entire sample from that whole entire data point, from the sample? Are you going to substitute? Some people will substitute the median in place of the outlier. And again, it's just it's a feel thing. There's no preset rule to what to do with outliers. That being said, it's definitely something you want to look for. Every time you have a set, one of the first things you want to do is, are there outliers in my set, and decide what you're going to do with them, because it's really bad to go through and do a bunch of calculations for a very large data set with all of the numbers in there, realize later that something is an outlier and you probably shouldn't have used it, because then you got to go back through and redo all of that stuff over again. So you want to identify early in the case, is there something in our set that we need to get rid of? There's plenty of ways to do this. Some people will use a box plot method where they draw out a linear line of all the different points in their set to figure out if something's an outlier. That works if you have a relatively small set where it's not going to take forever to put points on there. There's a formula method that you're going to see here in a few slides. Or another method is the Z-score method. So let's bust through these. For a box plot or a box and whisker plot, what it is it's a line that has 5 points that every information set will contain. And that's what's listed down here on the top. The min, the smallest number in the observation. The Q1, the first quartile, the spot in the observation where only 25% of your information is below. The median, the middle point. The third quartile, the spot in your observation where 75% of your data is below. And the max that you have within that range. Those are the 5 points that you're always going to have. And to make your box and whisker plot, what you do is you draw a box all the way from Q1 to Q3. That's the box in the middle. And then for the whiskers, you draw a straight line from Q1 to the min and Q3 to the max. Going through, you can have an incredibly skewed, as they call it, whisker that goes way off to one side here. And it might have an outlier. Well, how would you determine that it's an outlier? As a general rule of thumb, people will say that anything that is more than 1.5 times the interquartile range above the third quartile should be considered an outlier. Anything that is 1.5 times the interquartile range below the first quartile should be a low-end outlier. And that's generally, in theory, what they do. So for this set right here, this would have actually been the max, where this outlier is standing over here. But somebody went through, they did the calculations, they realized that that data point is actually more than 1.5 times the interquartile range above the third quartile. So it's got to be an outlier. And what they did is they moved the line for the max to the next highest observation they had, and then they denoted that outlier with a little asterisk. So that's how you would set up a box in whisker plot. You would have to go through, put all of your numbers in sequential order, use that to find out what your min is, what your Q1 is, what your median is, what your Q3 is, etc. Then go through after you found Q1 and Q3, do that 1.5 times the interquartile range calculation, and determine if there's an outlier, and then adjust your set accordingly. So that's in formula mode what the formulas are that you're going to use to find your limits of what you want to have in your data set that you wouldn't consider to be an outlier. Now, just because it's outside doesn't mean you have to get rid of it. You could absolutely leave it in the sample set, but you can get rid of it if you want to. The nice thing about this is you get to see a little bit of shape or skew of the box and whisker that you have. It lets you know how your data is set up. Like in this case, this is the median. This is the midpoint of it. We got our low number and we got our high number. And as we can say here, even if we chose to discard this outlier way off on the right side, the range, the physical space occupied, if you will, by everything above the median is much bigger than the space occupied by stuff below the median. So while this might be the midpoint, there's numbers in our observation over here that have to be well above the rest of our sample. It looks to me like whatever they were pulling right here seems to be that there's quite a bit of action, quite a bit of concentration of the information between the first quartile and the median, but after you get above the median, it really spreads out. So there's opportunity in these numbers for really, really high scores within that range. Another methodology for determining outliers is the z-score method. And this is a standard distribution. You might have seen one of these if you've been in a stats class before. And what it is it's a chart that follows the theory that no matter what you are pulling right here, most people are going to be around the average. There are going to be very few returns that you get that are exceptionally below average, and there's going to be very few returns that you get that are exceptionally above average. And the farther and farther you get away from average, the less and less people are going to occupy that space. So for the ease of an example right here, go with an IQ test, because they are set up this way. In every IQ test, the median is 100, and then the standard deviation is going to be 15. It's the way they're set up. The vast majority of people are going to be around average intelligence. What's that? Well, that's the top 68% right here, or middle 2/3, if you will. 2/3 of the returns that you get will typically be within one standard deviation below or above the mean. For 2 standard deviations below or above, it's 95%. So the vast majority of your population is going to exist somewhere in that broader range. By the time you get to 3 standard deviations below or above the mean, you're capturing pretty much all of the information. It's like 99.95% is typically what this range comes out to be. And that amount of people would fall within the range of 3 standard deviations below or above the mean. So back to the IQ. If the average is 100 and the standard deviation is 15, that means that almost 100% of people are going to fall between an IQ of 55 and an IQ of 145. And it makes sense. People that would be below that are, politely put, are very, very low functioning. Well, if you're above 145, you're approaching Mensa level genius. And there's not a lot of people that occupy those 2 spaces. The vast majority of the population is going to be between somewhere those 2 extremes. So what does it have to do with outliers? Anybody that is well above that 100%, either greater than 3 standard deviations below or 3 standard deviations above mean, would be an outlier. And to find that, you measure in z-score. And z-score is a metric that tells you how many standard deviations away from your sample average one particular data point is. And the formula for it is x, where x is the data point that you're looking for, minus x bar, the mean of the sample, divided by the sample's standard deviation, or S. And when you run those numbers through, you're going to get a number, the overwhelming majority of the time, that's somewhere between -3 and +3. But you may get one that doesn't fit that range, that little spread right there. You may get a z-score of like 5 point something. Well, if that's the case, that spot is 5+ standard deviations above the mean, which isn't going to happen barely ever. So if you're going to use the Z methodology to detect outliers, the rule of thumb is 3. If a z-score for a data point is more than 3 standard deviations above mean or more than 3 standard deviations below mean, it's an outlier. And you're in the same boat you were before. Do you want to discard that data point from your set because you think it's not representative? Or is there some reason you should have it remain in there and include it? And case by case basis will tell you what to do.